So once again, we will start with some example problems today, and we will start with some cases or some examples involving three-dimensional vectors. So let's start with this. So we have vector E given to us as, let's say, 12 I cap plus 16 J cap plus some Z K cap. Now we have to find the value of Z if magnitude of E is equal to 52. Okay, so that's our first question. And our second example, like this, that okay, so let us start with these two practice problems for today's session. Just work these out quickly and tell me when you get the answers. So hope all of you are feeling confident about the test coming up and all things are clear. If you want me to revise any concept or any particular formula, theorem, etc., then let me know on the chat and I'll help you out with that also. Today's lecture is a good opportunity for us to finish anything pending before your test coming up. So anyone got the answer for the first one? Okay, correct. Correct. Shravani and Vaishnavi both correct. Just putting up the answer here. Z should be equal to 48. Okay. Because magnitude of A x square plus y square plus z squares. Square. So you can simplify this, by just writing this like this. You can make the calculation a little bit simpler for this. We've got this 12 square plus 16 square plus z square is equal to 52 square. So what we can see here is that there's a common multiple of 4 everywhere. So we can make use of that over here. That will just make the calculation of the whole thing easier. So z square is equal to 4 square. If you take common, we have 13 square minus of 3 square plus 4 square. So z will become 4 into 12. Okay. But just one thing over here, because z is a component. Okay, so when we write this, it should come with plus minus. So there are two possible options of z. It is plus minus square root of 4 square into 12 square. That means it is plus minus. So there are actually two possibilities about z. Z can be plus or minus of 48. Okay. Because remember, z is the component of a vector. Okay. So it can be negative also. Z is a component of a vector. So it can be positive or negative. Okay. So the proper answer actually is there are two possible values of z, and that is that it's plus minus. So that should be here. It should be okay. So hope this is clear to all of you. Okay, now let's come to the second question. So I'm just leaving you with this whole solution once, but all right, let's come back to the second question. Try this one now, please. Anybody got the answer? So what you do in the second one is you first calculate a plus b plus c according to the vector algebra component method, and the resultant that you get a plus b plus c, it should be along the z axis. That means that resultant vectors x and y component should be 0. So here's your trick for solving this question. Here's a hint for it, that in the second question what you do is first find the vector r as the sum of a plus b plus c. Find it in component form. In terms of the three unknowns x, y, and z. Then apply the condition for the vector r to be along the z axis. So if the vector r is purely along the z axis, that means the condition for this is that its x component must be 0 and its y component must be 0. So when you do that, from this you will get the value of x and y. Okay. And then find the condition for its magnitude to be equal to 5. Okay. And from that you will get the value of z. Okay. So use this as the method for solving this question. Okay. So again I have a couple of students joining now. Yes, so anyone worked out this question, please send me the answer on the chat. Okay, so let's work this out. So let me pick up the values in the question. Well, try that again. Anyway, doesn't matter. Let me just manually put in the values. Two, 1 minus 1 and 1 minus 1. These are the vectors given. Now we have to find the condition. So we have to find x, y, z so that e plus b plus c lies along the z axis, okay, and magnitude of a plus b plus c is equal to 5. Okay, so let's work this out. So what we'll do is we'll denote the sum of a plus b plus c as the resultant vector r. So just calculate this in component form now. So it's the sum of the x components, that is 2 plus 1 plus x, plus the y components 1 minus 1 plus y, plus the z components minus 1 plus 1 plus the unknown quantity z k cap. Okay. Or from this we can see that the resultant vector r is 3 plus x I cap plus y j cap, okay, plus z k cap. Okay. This is the resultant in terms of the unknowns. Okay. Now apply the condition. The condition for the resultant vector, which is actually the sum of e plus b plus c, to be along the z axis, is that Rx should be 0, Ry should be 0. And if I'm saying along the z axis, I mean positive z axis, and z component should be positive. Okay. So let's apply that condition on this vector now. So in other words, x component is 0 means the quantity small x over here is minus 3. Okay. Similarly, the condition for y component to be 0, that implies that y is 0. Okay. And the condition for z component to be positive implies that the quantity z over here is a positive quantity. Okay, so this is what we're getting so far. X and y, z is still unknown, but we can see that it's positive. Okay. Now we use other condition, and the magnitude of a plus b plus c is nothing but the magnitude of this resultant R should be 5. So that resultant R now has become just Z k cap. So magnitude of this should be 5. So that means mod Z should be 5. Okay. Or in general, that means that Z could be plus or minus of 5. Okay. But here we've already seen that Z is positive. So we'll rule out the negatives root here. Okay. And supplying that, we'll see that therefore Z is 5 or positive of 5, and the resultant is 5k cap. The condition for that x was minus 3, y is 0, z is plus 4. Okay. So this is the complete solution of this question. And again, you can see it's nothing very complicated. It's just application of component algebra. Yeah, Dhrumi, we are using that only, but उसमें हमने पहले ही condition कर दिया ना that this thing is Rx and Ry is 0. No? So this condition that we are saying, it is that magnitude of R is 5. So that just means that square root of Rx square plus Ry square plus Rz square is equal to 5. But in this we already have, but already Rx is 0, Ry is 0. Okay, why? Because the resultant vector is along z-axis. So we have to make use of that first condition also. ये भी तो है. So this is telling us that Rx is 0, Ry is 0. So you incorporate that in the solution. Okay. So I'll just take you to the full length of the solution below. Okay, so hope this is clear to everyone. Yeah, so few of you have got this correct, but not everybody, unfortunately. Okay, so these were the first two questions. Okay. All right, now let's continue ahead. So hope this is clear to all of you. Okay. Now moving on, let's come back to some examples of the applications of our theorems. So if mod A is equal to mod B is equal to, let us say, 20, okay, and mod of A plus B happens to be less than 20. Okay. Then which of the following are incorrect? It is that kind of thing that you have to catch which option is the wrong option. Okay. So be careful when you answer. Okay. So option E is saying that mod of A minus B is less than mod of A plus B. Should be saying mod of A minus B is greater than mod of A plus B. Okay, so this is that slightly more tricky type of question. So take your time over it and understand which of the theorems you will use out of the inequality theorems and things we have discussed, and just try to work this out. So the hint to use that in this, you have to use the inequality theorems, the ones we have discussed about from the triangle inequalities. Vaishnavi, correct. Now you will have to check your answer. So I'll just give you a small hint to start with. This fact, along with this fact, if you put these two statements together, you can see that it's showing you that mod of A plus B is less than root of A square plus B square. This is what it is showing you. Or, so what does this mean actually? So once you understand this, that this is happening because 20 root 2 is actually root of A square plus B square, this term. Because A is equal to B is equal to 20. So root of A square plus B square, nothing but 20. So the moment you see this, so therefore what we can understand that therefore theta, the angle between them is obtuse, or cos theta is a negative quantity. The moment cos theta is a negative quantity, you have something to contend with. Okay? So the moment cos theta is negative, what we understand further is that A plus B will be less than root of A square plus B square, and at the same time greater than the difference of A minus B. And here the difference of A minus B is 0. So that means the range of values of A plus B is between 0 to less than 20. I'm sorry, 20 root 2. So this is one step. And also you can understand, because cos theta is negative, therefore mod of A minus B is in fact greater than root of A square plus B square. Okay. So mod of A minus B is greater than 20, but at the same time while it is greater than root of A square plus B square, it cannot also exceed the sum. So therefore in this particular case, mod of A minus B lies in this range of values. 40 से ज़्यादा नहीं हो सकता है, but at the same time 20 root 2 से ज़्यादा होना है. It has to be greater than this but less than equal to 40. So these are the range of values. Mod image. Okay. So now from this you can start ruling out the options. So you see that according to these two inequalities, now this option is correct because it can be less than 20, because it can be anything between 0 and 20 root 2. It can be 10, it can be 15, it can be anything. It can even be 0 actually. Interestingly, it can be 0 also. Similarly, this has to be greater than 20 root 2. Yes, that you are seeing is correct. Okay. And therefore, obviously, this quantity is greater than this. So this option is also correct. So the wrong option is which one? E. So the answer here should become the option E. The answer is E is the incorrect option. Okay, so I'll just take you through the whole thing once more. So these are the slightly advanced type of questions in vectors which you have to be extra careful about. This JEE type of question related to vectors. This kind of logical thinking, this kind of ruling out of options using inequalities and things like that. This is the level of the analytical thinking you are expected to do in JEE type of questions. Very rarely there will be directly formula based type of questions. Okay, so people hope this question was fully clear. Okay, let's do another question now. This time let's pick up a numerical question again instead of inequalities. So given that magnitude of the vector E equals the magnitude of the vector E plus B equals to 20 units. Okay. And the vector E plus B is at 120 degrees with respect to the vector E. So you have to find the magnitude of the vector B and the angle between A and B. So you can think this is like back to the early part of vectors. Application of just the sum of two vectors. You can use triangle law concept also, or you can also use the component method. So this question can be done by both the methods, component method as well as the triangle law method. So just try this one out also, people. Anyone worked out? Yeah, getting some couple of answers now. Let me check. Not yet. I'm waiting for the correct answer, people. the question is clear to all of you. Let's interpret what the question means. Okay, that we have some kind of a vector E. Let's say like this. Now E is of magnitude 20 units. Now the resultant of E and B is at 120 degrees to it. That is also magnitude 20. This is the resultant of E plus B. And that is not only of magnitude 20, but this angle is 120 degrees. Okay. So now it's asking what about the vector B and what about the angle between them. So if you complete the vector triangle here, you will see that the vector B must be this one. This must be our vector B. This must be the angle theta between E and B. So given that magnitude of R is equal to magnitude of E is equal to 20 and the resultant is at 120 degrees with respect to E. You have to now find mod B and so this is what the question reduces to now if you interpret it geometrically. Now rest is up to you. From here you can apply the formula of triangle law or you can use geometry or whatever, or you can also convert this to components. Always have the option if nothing else is working out for you. You can convert this information to component algebra. No, unfortunately that answer is not correct. Shravani, you have to check your calculation again. Anyone else? Ishika, no, unfortunately, theta is not 60. As you can see in the question, that angle has to be an obtuse angle. So it cannot really be 60. Okay, so let's see what all methods we can apply here. I will do by one method first, then you can try by two other methods yourself. So the first thing I'll do here is I'll try and use any principles of plane geometry that I can. So if I use just principles of plane geometry, so this diagram here, you can see that because I have this side is equal to this side, they are 20. So therefore, whatever this angle is, that will have to become equal to this angle. So let's say this angle is some beta. Okay. So this angle is also equal to beta. So that's the first thing. It's making use of the fact that it's an isosceles triangle. So angles which are opposite to equal sides are also equal. Yes, Ishika, correct. The angle you have given is correct. Okay. So angles which are opposite to opposite sides, to equal sides, will also be equal. So make use of that, and from that you can see that 2 beta is equal to 60. So beta is 30 degrees. So that immediately tells you that theta is equal to 180 minus beta, or that unknown angle theta is 150 degrees. Now you see what use you can make of this and solve for the other thing, which is the unknown magnitude of the vector b. Now you have to also find for the magnitude of the vector b. So just use this as a hint over here and see if you can solve for this second thing. Just try this out. Yeah, so Ishita, you'll get the magnitude as 20 root 3, not as root 3, you get the magnitude. So now the option is here, you can use this, that the resultant's magnitude is root of a square, yeah, correct, plus b square plus 2ab cos theta. So the resultant's magnitude is 20, that is square root of 20 square plus b square plus 40b cos 150. Okay. And you use this relation that cos 150 is equal to minus cos 30. So that is minus root 3 by 2. So from that, what we'll get here is that 20 is equal to square root of 20 square plus b square minus 20b root 3 as I have taken. Now square both sides. So 20 square is equal to so b square minus 20 root 3 times b should be 0. So obviously b cannot be 0 because b is a non-zero vector by magnitude. So therefore b is equal to 20 root 3. So that becomes the final answer. So the magnitude of the vector b in this case becomes 20 root 3 and the angle theta between a and b was 1/3. So this you can say is like the primary method of solving the question. Okay, people, so hope this method is fully clear. Now, the reason I've selected this question again is because we can also practice some component algebra from this. So what we can do is the alternate method of solving this. First, let me check all your messages. Yeah, so everybody is good with this. Good. Now, I'll also show you another way of doing this question, which is going to help us practice our component algebra in 2 dimensions a little bit here. Okay, so the alternate method solved by component algebra. So given this information that magnitude of vector A is 20, magnitude of vector A plus B is also 20, and E plus B is at 120 degrees with respect to E. Okay, so using this information now to solve it, let us set up the question like this. Okay, let us assume that vector A and B lie in the xy plane with the vector A along the x-axis. Okay. And there's nothing wrong in this assumption because nothing is said to us in the question about the xy plane. So that means we as the problem solver or as the user can set our xy axis wherever we please. So vector A jahan par bhi hai, we'll just assume our x-axis is along that direction. And whatever plane A and B are lying in, whatever two-dimensional plane, we'll just assume that is our xy plane. So with that assumption now in mind, we can see that geometrically our picture will become like this. If this is the x-axis and this is the xy plane basically for us, this is our chosen system of coordinate frame such that we are now assuming that our vector E is lying along the x-axis. So in our system now, this is what the vector E looks like, right? So in our system, this is what the vector E is. And now in comparison, what we have is that the resultant of A and B is at 120 degrees to A. So we can assume that the resultant is like this. This is the vector which is the resultant of A and B. This is E plus B. And using the information above that the resultant is also magnitude 20 units and is making an angle of 120 degrees with respect to E. That means this angle here is 120, whereas the original vector E was 20. Okay. So this is how I am incorporating the information given in the question, that is this information here. ये जो info मुझे दिया हुआ है कि mod A is 20, mod A plus B is 20, and the angle between E plus B and E, that is 120. So the resultant vector is making, so I can incorporate this like this. And now using this, I can express the vectors in component form. Therefore, in component form, now I can express the vector vectors E and B like this. The vector E will become 20 I cap. And what about the vector E plus B? It will become, now just use algebra. So this is 20 cos of 120 degrees. That is the x component. And 20 sine of 120 degrees. That is the y component. Okay. So just use this now to define A plus B. And then from that we can define the vector B by just subtracting it. Just excuse me for a moment, just work this out for me. Okay, people. So hope this is clear. So just solving this one step further. Okay, now you can see that from this now E plus B can be written as, now you know that cos 120 is minus cos 60. That is minus half, so it's minus 10 I cap. Sin 120 is the same thing as sin 60, so that's root 3 by 2. So this is 10 root 3 j cap. So now you see you got vector E and you got vector E plus B in component form. Okay. So what you do next step is very simple. You subtract these two. So you get the vector B. And then from that you can analyze both the things. Okay. Let's say this is my equation 1. And this one here is my equation 2. So next step what you do is equation 2 minus 1. And that's it, you're done. So by doing that, you'll get the vector B. And that's it. Then you know mod B. And you can find out the angle theta between A and B. Because A is already along the x-axis. It's very easy to figure out the angle. Yes, good, correct. Okay. So doing this operation, you can see that the vector B is the difference of A plus B and E. Okay. So when you subtract these two vectors, subtract their x components. So it is minus 10 minus of 20. So A's x component is this plus 10 root 3 minus 0 j cap. So the vector B is becoming minus 30 I cap. I just saw that is an answer that one of you have sent me, so that's correct. So magnitude of B is becoming root of 30 square plus 10 root 3 square. So you will see that will be the answer we just got over here. So you can take here 10 common and you have 9 plus 3. 20. So that's done. And as far as the angle is concerned, again use component concept. Okay, so you get the angle. Okay, so the other thing here is once you've got the vector B like this, you can see that theta, which is the angle of vector B with respect to the x-axis, okay, which will also mean it is with respect to E, because E is already along the x-axis. So वो theta कैसे निकालेंगे? So remember that concept of component algebra. Given a vector, how to find the angle with respect to the x-axis. Okay, so B is minus 30 I cap plus 10 root 3 j cap. So that means theta is in which quadrant? It's in quadrant 2, because x component is negative and y component is positive. Okay, and tan theta is Vy by Vx. So that is 10 root 3 divided by minus of, so this will become minus 30. So we have this thing that tan theta is minus 1 by root 3 and theta is in second quadrant. That is theta is between 180 and 90. Okay. So we'll use second quadrant formula. So therefore tan of theta is minus of tan 180 minus theta minus 1 by root 3. So that means tan of the supplement of this angle is 1 by root 3. That means 180 degrees minus theta is 30 degrees. So theta is 150 degrees. So this 150 degrees that we are getting for theta, this is the angle of B with respect to the positive x-axis. Okay. And that is the same as the vector E, because the vector A is already lying along the positive x-axis in our system. So that theta is actually the same angle that we are looking for in the first place. That is the angle between the vectors E and B. So as you can see, this is a little bit more lengthy. Okay, but component algebra sometimes gives us more number of steps, but it will invariably give you the solution for any question. It is like a brute force method. That force can be that method can be used to calculate the answer by brute force for any given question. It might not be a elegant kind of solution. It might not be a solution which has a lot of symmetry and shortcut or anything like that. But it will give us the answer finally. After solving all the steps, it will definitely give us the answer. Okay, people, so hope this is clear. Right, now let's move on back to an example of a three-dimensional type of question. Okay. Now, a particle makes a displacement S1 of, let us say, magnitude 50 meters at 37 degrees north of east. Then S2 of magnitude, say 10 meters towards south, towards west. And finally, S3 of 30 meters vertically up. So imagine he climbs a straight ladder, climbs a vertical ladder. 30 meters is a huge amount. It would be something like 9 floors he's climbing straight away. So anyway, so vertically up. So find the magnitude of his net displacement. This is just again to give you a bit of practice with the three-dimensional component system. So just try this out, people. So anyone got the answer? So again, the idea is very simple. If you take your xy plane in the horizontal plane, so xy plane is the horizontal plane such that, let's say, I cap points towards east and j cap points towards north. So if I do that kind of system of axes, it will also mean that my z axis is the one which is pointing vertically. So this is eastwards, this is northwards, and k cap would be vertical. So now looking at the geographical directions which were given, your S1 was a displacement of 50 meters, like this. Such that this angle was 30, and S2 was a displacement which was 10 meters in this sort of direction. Towards west. And S3, you cannot show in this diagram because it's perpendicular to this plane, but S3 is going to be vertical displacement of 30 meters. So using this now you can see that K cap is vertical. So S3 as a component system would be written as in meters. Okay. And likewise, now you can see your S1 and S2 can be written very, very easily in the component system. So S1 will just become 50 cos 37 degrees I cap plus 50 sine 37 degrees. J cap. So that you will see will become 40 I cap plus 30 J cap. So S1, when you write in component form, it is 40 I cap plus 30 J cap. And S3, you don't have to do anything extra. You can see in the diagram itself. S3 is pointing, rather S2 is pointing towards the west. So S2 is very simply minus 10 I cap. So now you just sum up these three to find the net displacement in three-dimensional component form and then find its magnitude. That's all you have to do. So this question becomes actually as simple as that once we incorporate this three-dimensional system. So quite an easy question, as you can see. Okay, so people done with this? Anybody got the answer, the final answer? Yes, very good. So its magnitude now you can see will become 30 root 3. So the net displacement, for which we have to just do the vector sum of S1 plus S2 plus S3. When you work out that vector sum, you will get 30 I cap plus 30 j cap plus 30 k cap, all of them in meters. Okay. So the magnitude of your net displacement will become magnitude of 30 I plus 30 j cap plus 30 k cap, which by definition you know is root of x component square plus y component square plus z component square. So that becomes 30 root 3 meters. Okay. So this actually tells me that if I were to make a straight line from his starting point till the top of the ladder which he climbed, which is his ending point, then that straight line would be of length how much? 30 root 3 meters. This is what this finally telling us in terms of information. Okay, so I think this should be abundantly clear now. Now let's move on to something a little bit more advanced in our study of vectors. We'll do another theorem actually, but this time we'll do it as a proof question. We'll do the theorem itself as a sort of proof question. So this example, what we have to do is prove that if the resultant sum, okay, and the difference of two vectors are perpendicular to each other. Okay. Then the two vectors must be of equal magnitude. So this is like one of the more advanced theorems in vector algebra. So we'll first interpret the language of the theorem also, and then we'll see how to prove it using the principles that we already know. So first of all, go through the language and make sure you understand what it's saying. That it's not saying the two vectors are perpendicular to each other. It's just saying that the sum of the two vectors, the resultant sum of the two vectors, and the difference of the two vectors, those two are perpendicular to each other. Then it must imply, or that condition is only possible when the two vectors are of equal magnitude. Okay, this is the condition that is you've been asked to prove. Okay. So let us convert this statement, okay, to vector notation. So in other words, what it's saying is that if A plus B is perpendicular to E minus B, okay, then magnitude of A must be equal to magnitude of B. Then it implies that the magnitude of A, so this thing implies this. Okay. This is what this statement is basically saying. And next we will see multiple ways of doing the proof of this. Okay. So try this out. So I'll give you a couple of hints on how to do this. Okay. One is you can use component method. Take A plus B to be along x-axis and A minus B along y-axis. Or you can take Z also, it doesn't matter, but they are mutually perpendicular. So take them along each axis and prove. Use that. Okay. Or secondly, you can also go by geometry. So if you go by geometry, use parallelogram law. Use the vector parallelogram for vectors A and B. And the condition given. What is the condition given exactly? That the vector A plus B is perpendicular to the vector A minus B. Okay. So let's see how we can do these by using either of these two methods. Just try out one or the other, whichever you feel more comfortable with at this stage. Whether to go with the component method or to go with the geometrical parallelogram law kind of method. Okay, people. So hope some of you got this. So if you go by the component method, it's actually quite easy. You say that I don't know the magnitude of the sum and difference. I only know that they are perpendicular to each other. Okay, so suppose assume E plus B is some xi cap. Okay. I made an assumption. Okay, where x is an unknown quantity, and E minus B is yj cap. I could have written this as minus yj cap also. I could have written this as zk cap also. But the important thing is A minus B is perpendicular to me. Okay, so this is again an assuming. So because it is given to me that A plus B is perpendicular to A minus B. So from that part of the statement, I made this assumption. And y is also unknown. So now it's like this, that if this is equation 1 and this is equation 2, adding the two, we get 2a is equal to xi cap plus yj cap, or the vector A can be written as x by 2 cap plus y by 2 j. And subtracting the two equations that I have written, that is this one and this one. So I'll get A plus B minus of A minus B. So I'll get 2B. On the other side, I'll get xi cap minus of yj cap, or the vector B is whatever this x and y is, but it is x by 2 cap minus y by 2 j. Okay. Now you can see the magnitude of E is mod of x by 2 whole square plus y by 2 whole square. So that is root of x square plus y square by 2. And mod of B is also the same, because B's components also have the same magnitude. So the fact that this is minus y by 2 doesn't make any difference, because we are talking about the magnitude. Okay. So hence prove that mod A is equal to mod B if E plus B is perpendicular to A minus B. So this is the simple proof of this theorem. So hope this is clear to everybody, people. Do let me know if there's any confusion with the steps and things. Okay. Okay, did anybody figure out the geometrical method of proving this? Can you tell me geometrically what will be the condition that mod of a, the vector e plus b should be perpendicular to the vector e minus b? What does that mean about the parallelogram? In a vector parallelogram, what are the diagonals? They are a plus b and e minus b. So if we say that a plus b and e minus b are perpendicular to each other, what does that tell us about the parallelogram? That is actually a rhombus. A rhombus is having that property that diagonals are perpendicular bisectors of each other. And the rhombus also has the property that the sides are equal. A rhombus is basically nothing but a subset of parallelograms, such that within that subset, all the sides are equal in the parallelogram. If you make the sides of a parallelogram perpendicular to each other, you get the subset of parallelograms which is rectangles. Similarly, if you make the condition that in your parallelogram the sides are equal in length, then you get the subset of rhombuses. And rhombus as a geometrical figure has that particular property that the diagonals perpendicularly bisect each other. So they are perpendicular to each other. Okay, so you can also see this by the geometrical method. So geometrically we can understand this way, that okay, if e plus b is perpendicular to e minus b, so that means that the diagonals of the vector parallelogram, okay, formed using vectors a and b, so the diagonals are perpendicular. So that means that the vector parallelogram by definition is actually a rhombus. Okay. And it has equal sides. Okay. So, geometrically we understand it this way, that my vector parallelogram will be either formed by two vectors a and b which are at an acute angle, so they would look something like this. So this is one possibility. Okay. So when I complete this parallelogram now, and I impose the condition that e plus b is perpendicular to e minus b. Okay. When I impose that condition that the primary diagonal, which is this one, and it becomes the resultant sum, and the secondary diagonal, which is this one, which is the difference e minus b. Now when I impose the condition on this that this angle is 90, they are perpendicular to each other, then automatically I impose a condition that this side must be equal to this side. Okay. That is the condition of. So this could be one possibility, or another case of the rhombus that looks like this could also be like this, that the two vectors a and b are actually at an obtuse angle with respect to each other. But once again, we'll impose a condition that the diagonals are perpendicular. So when we impose that condition that the diagonals are perpendicular, we'll see that we'll get the condition that the equivalent parallelogram that the system is giving us, that has to reduce to a rhombus. It cannot be any other type of parallelogram. Or in other words, it cannot be a parallelogram where the sides are not equal. So again, the condition for this angle to be 90 is that this side must be equal to this. So basically, rhombus by definition is a parallelogram with equal sides. And the properties of a rhombus are that the diagonals are perpendicular. Okay, that's one thing. Secondly, the diagonals bisect each other. And also another important property of rhombus is that the diagonals are angular bisectors for the interior angles between the sides of the parallelogram. Okay. So here we'll see that we have just made use of one of these special properties. We made use of this property that the diagonals are perpendicular to each other for a rhombus. Okay, so I'll just take you through this whole thing once more. So this is like an interesting set of properties to remember that when your parallelogram is reduced to a rhombus because the sides are equal in magnitude, then the rhombus also displays these other properties, which then applies to the vector algebra. So this is basically telling us that if mod A is equal to mod B, it means that A plus B is perpendicular to A minus B. Okay. And also A plus B bisects the angle theta. That's another theorem. We'll come to that another day. So this angle theta is getting bisected by this primary diagonal. This angle theta here is getting bisected. Okay. So this is an example where theta is acute. This is an example where theta is obtuse. Okay. And you all know that if we take the in-between case where theta is 90, then is a special rhombus which is called a square. Now, all four sides equal and the angle is 90. So even square has that property that the diagonals are perpendicular to each other. Because square is a further subset of rhombus. But for example, a rectangle is not subset of rhombus because rectangle by definition has different sides. Okay, so this is just one of those interesting advanced theorems in vectors. Yeah, I'm coming to that. Okay. So anyway, we'll conclude the session here today, and with this, just make sure you revise particularly the worksheet 4 and 5 problems once again, and also the solved examples we did in the last lecture, not only today's lecture but also the last lecture. So if you just do this much before your test, worksheet 4 and 5, last lecture's solved examples and today's lecture solved examples, you will be very well prepared for the vectors. You don't need to do anything else. Okay? You will find most of the questions very easy to solve. You will be well in position to score 100% in your vectors part. Okay? So with that, I'm concluding today's session, people. Wish you all the best for the upcoming test. Okay, that's it for today. And as usual, stay safe and keep occupied and all that during the extended lockdown as much as possible. It's frustrating for all of us without any outdoor activity and normal social life and things, but we just have to make do of what we can. Okay. So all the best again, people. I'm sure you will crack the exam on Sunday without any difficulty. Bye for now, and we'll catch up soon. Send me any doubts if anything comes up today, tomorrow, day after, anything last moment. Make sure you send me the doubts.